Hello students. In today's class we are going to start chapter number 3 of our physics syllabus, and that is current electricity. I am going to introduce you to the current electricity today, and from tomorrow onwards we will see the upcoming topics. Previously in chapter number 1 and 2 we have read about our electrostatics. So all these electrons, protons, which cumulatively known as charges, whether they are free or bound, they can be free in this space, roaming here and there, or can be bound within an atom, all were considered at rest. That's why we are saying it as electrostatics. Electro is something carrying the charge, and static means something at rest. So these were the things we have studied in the previous chapter. So we'll just get a quick recap over it. We learned about the force lines. We learned about the flux. Then we have learned about the charges and their Coulombic interaction. And so on. In the second chapter, we read about the potential and capacitors. So now it's the third chapter, which is with respect of these electrostatics only. Previously we said that our charges are at rest. Now we are saying that when the charges are moving, what happens? It's time for us to know the other side of the coin, which is the charges are not at rest. V of the charge is not equals to 0. Now what happened? Now the charges in motion constitutes an electric current. Whenever the charges are moving to or fro, they tend to pass the current. They will make electric current. Such currents occur naturally also in many situations. So in our day-to-day life, we can see the flow of charges, where we will see the flow of current. The current flowing in your household is nothing but the motion of charges. One of the example which is mentioned is lightning. What is lightning? It's an atmospheric phenomenon which we are able to see when the clouds get highly ionized under some circumstances. Mostly these circumstances are all about the rainy season. So when these clouds get highly ionized, these ions, these charges start moving from the surface of this cloud, towards the Earth's atmosphere. When they are moving towards the Earth's atmosphere, they tend to show something like lightning. So when they are moving, we are able to see they are showing some motion. That the motion is known as lightning. These lightning have disastrous effects also. Like if the intensity of this atmospheric lightning is extremely high, it can damage the surfaces on the earth, the buildings, the cars, or any other thing which is having metal. Now we see that charges flow, charges move. So is charges moving uniformly always? No, they move both as uniform as well as non-uniform. So what is the correct terminology which we are using for the same? One is the steady state and other one is the non-steady state. Steady state follows up uniform motion. Uniform motion can be seen in the rivers, where water flow in straight lines, no turbulence is seen, no tides are seen, like the oceanic waves are up and down. They are not uniform. Sometimes a wave comes with extreme high intensity and sometimes the wave is very low. So that is non-steady. Okay, so with the example of our river water and ocean water, we can understand steady state of current and non-steady state of current. Now the question arises, is non-steady state of current needed in our day-to-day life? We'll say this is not needed in our electrical appliances. Why? Because it's a non-steady state. Sometimes this non-steady current will flow with a voltage of 200. Sometimes it will flow with a voltage of 400. So what will happen? Our electrical appliances they have a threshold voltage. If this threshold voltage is exceeded, there is high chances that our electrical appliance will get damaged. One of the best example which in our day-to-day life we can see is refrigerator. This refrigerator nowadays in modern days is coming with a inbuilt stabilizer. In olden and the golden days we have seen we used to attach a external stabilizer for the refrigerator. What this stabilizer usually do is this stabilizer stabilizes the flow of current so that our refrigerator will not get current beyond this threshold and will not get damaged. So mostly in our household and day-to-day life we do not need a non-steady flow of current, but of course we need the uniform flow of current. One of the example provided in the textbook is steady flow of charges is seen in a torch and in a cell driven clock. Any clock having the cell, they will give you a very steady flow. So this is the introduction part. Now I'll be explaining you what all we are going to read in the chapter current electricity very briefly, just like within few seconds, so that we all will have a broad idea what we are going to learn and how these learnings going to help us. So first thing, in current electricity we are going to define what is a electric current. We know that flow of charges produces current, but it is extremely important for us to know what is current. Now with respect to current we will read conductors and insulators. The next thing which we are going to read is where do this electric current have more efficiency, flowing efficiency? Is it the conductor or the insulator? Then next thing which we are going to read is Ohm's law. Ohm's law is a very important law which is derived with respect to electric current, and it gives us a relation between current and voltage. Always remember, Ohm's law gives us relation between current and voltage. And when we'll see Ohm's law, we will going to see about the conductivity and its counterpart, that is resistivity. And from the resistivity we are going to define what is resistance. And from here over we will read about many other aspects like the effect of temperature on the resistance or like Ohm's law. Then we will read about electrical energies and power. Electrical energies and power. And then we'll read about cells, EMF, internal resistance, cells in series and parallel. So all about cells. And then I'll take one special class on the parallel combination, parallel and series combination of resistors. And at the end we will see few applications like potentiometer, Wheatstone bridge and Kirchhoff's rule. Kirchhoff's rule, and with respect to this rule we will see what is a potentiometer and what is a Wheatstone bridge. So these are the things we are going to read in our chapter number 3. So this is just a brief introduction to the chapter number 3, and we'll start up our topics from the next class onwards. So have a good day. Bye bye.